So this is technically day 2 on dividing polynomials, right? Now, what I started off with was the hardest part, long division. Long division of polynomials, where you had like a polynomial divided by a binomial, right? Does anybody need me to review that one more time? No? Was everybody able to finish the assignment? We did the bottom half of this worksheet, 18 through 24. No? Okay, you guys need to practice. So whichever problem we're looking at, whether you're doing long division or the new method that we're going to learn in a couple of minutes here, you want to represent every single power, every single term of your polynomial. So on 23, the top one goes inside of the division box, the denominator goes outside, right? Now, we have a p to the fourth, we don't have a p to the third. So you're going to have to fill that in with a 0 p to the third. Does that make sense? So to set up 23, didn't I explain this on the video? No? Yeah, so inside of the division box, I'll just do the first part, setting it up. You're going to put 4 p to the fourth. Now there's no p to the third, so you're going to put no p to the third. And then you have the minus 17p squared, you have the plus 14p, and you have the minus 3 at the very end. So the idea is this, guys. It doesn't matter what you have to have every single power represented. P to the fourth, there's no p to the third, so that's going to be with the 0. That means that there's no p to the third. There's a p to the second, there's a p, there's a constant. Constant's the very number at the very end with no variable. Okay, so you're always going to set that up, and the denominator, the 2p minus 3 is going to go out here. Okay, and we did explain this on the previous video, so watch that other video if you need it. Now, number 24, I know a lot of people get confused with 24. So let's just do this one as a review. Okay, so what goes inside of the box? The 2h to the fourth minus h to the third plus h squared plus h minus 3. There is no missing values. That's beautiful, right? Okay, so that goes inside of the division box. What goes on the outside? H squared minus 1. But I have an h squared and it's missing an h, right? So in order for me to stay organized, just like before, just like over here, I needed that missing p to the third, I put it with the 0 p to the third. I need to do the same for this one. Anytime you have missing powers, you have to represent them with a 0, with the coefficient of 0. So yes, I do have the h squared, but I want to put a plus 0h because there is no h's, and then I have the minus 1 at the very end. Now, just like on long division, you don't think, well, how many times will this guy go into this guy? You don't think of the whole thing, right? You just look at the first term and the first term. So let's look at our first term, h squared, and look at our first term, 2h to the fourth. So h squared times what will get us that identical value, 2h to the fourth? H squared times 2h squared. Yes? H squared times 2h squared will get us this identical value, 2h to the fourth. So where am I going to write the 2h squared? I'm going to write it right above the other h squared terms. So I'm going to put the 2h squared right above the other h squared terms. Why? So I could stay organized. Okay, I'm not going to put it on top of the h to the third or on top of the h to the fourth. I know that h squared times 2h to the second will give me 2h to the fourth, but I write that above the other h squared terms. And now it becomes a distribution problem. 2h squared times h squared, we said, would give us that exact value, 2h to the fourth. 2h squared times 0h, well, that's just going to be 0h to the third, which is still nothing, right? So I'm going to put plus 0h to the third. I don't even have h to the thirds, but I'm writing it because to keep that spot there, to make it more clear to me, to stay organized. Finally, 2h squared times negative 1 is negative 2h squared. And yes, we are subtracting. And on long division, I say put parentheses around your polynomial with the subtraction on the outside. That way it'll help you remember that you're distributing it into each and every term. So that minus sign is going to go to the 2, it's going to go to the plus 0, it's going to go to the minus, right? So of course, right here, the 2h to the fourth, take away 2h to the fourth is gone. That's why there's nothing here. A negative h to the third with a negative 0h to the third, that's nothing, right? So negative h to the third is simply going to be negative h to the third. Everybody with me? Yeah. Okay, only one person, I got it. And then negative, that's a positive. So I have a positive 1h squared plus 2h squared. What's that? plus 3h squared. And what do we do next after subtracting? Bring down the next value. I take this h and simply bring it down, so plus h comes down. And once again, you look at your first term, h squared times what will get us that exact value, negative h to the third. Negative h. So let's put negative h. Notice that I'm putting it right above the other h's. I'm not going to put it on top of the h to the thirds or on top of the h to the fourths. H squared times negative h, I put on top of the other h's to stay organized. So negative h times h squared is negative h to the third, that exact value. Negative h times 0h is going to be a negative 0h squared, which is nothing, but I leave it with the 0, with the negative 0 in front, just to hold the value right there, the place value. And then at the very end, negative h times negative 1, that's positive h. And again, I am subtracting, so I put parentheses with the minus sign on the outside. So what happens here, this one becomes positive, which cancels. This one becomes positive, but it's really nothing. So I really have 3h squared plus nothing. That stays 3h squared. And then at the very end, that negative changes to a minus h. The positive h and the negative h cancel out. And for the sake of staying organized, I'm going to write it as a 0h. So anytime I have a missing value, I'm going to put the coefficient 0 in front of it to stay organized. At the very end, I take that minus 3, bring it down. I have a minus 3 at the very end. Once again, h squared times what gets us this identical value, 3h squared? Tell me. H squared times what gets us 3h squared? 3. So let's put plus 3. And when we distribute, 3 times h squared is 3h squared. 3 times 0h is 0h. 3 times negative 1 is negative 3. And of course, we are subtracting. Put parentheses around the whole thing. Distribute the minus sign to each and every term. And guess what? Everything cancels out. What does that mean? There is no remainder. There is no remainder. So what's our final answer? 2h squared minus h plus 3. Any questions? That's long division. So again, I emphasize, you have to have, on your polynomial, you have to have every power represented. 4, 3, 2, 1, constant. 2, well, you need the 1 and then the constant. So 2, 1, constant. Over here, when we set it up, 4, 3, the 3 is missing, so that's going to be 0 p to the third. 2, 1, constant. 1 constant. So you need to represent every single term. All right, so I hope that we paid attention yesterday. I hope that we know how to do long division. Now, I assigned only 18 through 24 because those are the hardest ones with long division. The first half is way easier, and I do not, again I repeat, I do not recommend long division. Long division is horrible for the first half. Why is that? Imagine that. You'd have to write this in the box, right? But you would have to write it as 15 r to the 10th plus 0 r to the 9th minus 5 r to the 8th plus 0 r to the 7th plus 0 r to the 6th plus 0 r to the 5th plus 0 r to the 4th. Forget that. I mean, it's going to be a huge, ridiculously disgusting problem. So in order to do this one, let me review something very basic, going back to like the 6th grade, 5th grade. If I have something like 4 plus 10 divided by 2, what's my answer going to be? It's going to be 7, right? Because 14 divided by 2 is 7. So whenever you do have addition or subtraction, kind of like I have up here, addition and subtraction, and it's divided by something, by a single term, when it's divided by a single term, I could take that single term and split it. I could split it to both 4 and 10. Now, I wouldn't do this, but just let me show you that it does work. 4 divided by 2 plus 10 divided by 2. All I did was take that the divisor of 2 and put it on each of the terms. 4 divided by 2 is what? 2. 10 divided by 2 is what? 5. So what is 2 plus 5? 7. Same exact answer, right? If you did 14 divided by 2, it gives you 7, right? So I just reviewed something basic so you could apply it here on something more complex. I shouldn't say complex because then you're going to think imaginary numbers. But we're going to take this denominator and split it to each and every term. Now you can't do that if you had a binomial. If you have a binomial, I mean, you could, but it'd get really ugly. So I only recommend splitting it up when it's a monomial, one single term. It doesn't say 5r minus 2 or 5r plus 7. It's just a 5r to the fourth, just one single term. So let's divvy that up to each and every term. So I'm going to have 15r to the 10th divided by 5r to the fourth minus 5r to the 8th divided by 5r to the fourth plus 40r to the second divided by 5r to the fourth. So all I did was take this denominator and put them on each and every term of the numerator. Any questions? Now after that, we're going to use the previous section rules of exponents to cancel things out. So when I look at the 15 over 5, 15 divided by 5 is 3, and that 3 is going to be left over up on top. I do have 4 r's on the bottom and 10 r's up on top. 4 of those r's will cancel with 4 of those, and you'll have 6 left over up on top. 5 cancels with 5. 4 r's on the bottom cancel with 4 of the 8 up on top. You will have 4 left over up on top. 40 divided by 5 is 8. 40 divided by 5 is 8. The 8 is left over up on top. There's 2 r's up on top. There's 4 r's on the bottom. 2 cancel with 2. There's going to be 2 left over on the bottom. So what's my answer? My answer is 3 r to the 6th. No more fraction. There was nothing left over on the bottom. My second term is going to be r to the 4th minus r to the 4th. No more fraction because there was nothing left over on the bottom. And my third term will be a fraction. It'll be plus 8 over r squared. Way easier than long division, huh? So my goal yesterday was get you through the hard stuff and then teach you the easy stuff today.
So we could do that on the bottom part?
We can't do that on the bottom part. Why? Because imagine, because you have a binomial, that's why. You have a binomial. So if you put 6t to the third over 3t plus 1, you can't cancel anything out, right? Because it's a binomial. So that's why we need to do long division on these. Where you have a binomial, use long division. But if you have a monomial, like on the first half of this worksheet, go ahead and split it up to each and every term. Would you like to see another one? Which one? Number 2, 3, 4, 5, 6. Which one? 5? 6? Well, 6 is a little bit more challenging. You guys want for? Yeah, 6. 6, a little bit more challenging. Okay. All right. So here we go, guys. We do know that this is a division problem because there's a power of -1. This is going to go on the bottom, right? Remember, rule of exponents, this guy has to go underneath. So you really have that top one divided by 4dk squared. Yes? And we just said that if you're dividing by a monomial, it doesn't say 4d plus k squared. It doesn't say 4d plus 5 or 4k plus 7 or 4k minus 3. It's simply a monomial. It's all multiplication. There's no pluses or minuses, dividing it up into more terms. So when you're dividing by a monomial, you could take that monomial and place it underneath each term of the polynomial that you're dividing by, or dividing. So what are we going to set up? We're going to set up 28 d to the third k squared divided by what? 4dk squared. And then the next term is going to be plus d squared k squared divided by what? 4dk squared. And then the last one minus, and we have 4dk squared divided by what? 4dk squared. Now notice that the plus sign that was in front of the d squared k squared, I didn't put it right in front of it over here. I knew I was going to make a fraction, so I put the plus out here in front of the fraction. This minus sign that was right in front of the 4, I didn't put it right in front of the 4. I put it out here in front of the fraction because I knew I was going to make it its own fraction. So now it's all about canceling things out. So on the first fraction, 28 divided by 4 is 7. That 7's left over up on top. I have 3 d's up on top, 1 d on the bottom. 1 d canceled with one of those. I will have 2 left over up on top. I have 2 k's up on top, 2 k's on the bottom. They both completely cancel. There are no more k's. My first term is 7d squared. Second term, well, there's 1d on the bottom that cancels with one of these 2 up on top. So I have 1d left up on top. I have a k squared up on top and a k squared on the bottom. Both k's cancel with each other. There's no k's left. So my middle term is a fraction, d over 4, which you could also write as d or 1/4 d, but either way is totally fine. And the last one is really easy, ridiculously easy, because if you think about it, you have a 4dk squared up on top and a 4dk squared on the bottom. It's the whole exact thing on top and bottom. So that's just going to be a 1. Yeah, this whole thing cancels with that whole thing, minus 1 at the very end. Ladies and gentlemen, that's your answer. Easy, right? Way easier than long division. Again, I started with the harder stuff. I want you to practice that harder stuff. I want you to have more time with that harder stuff. So if you still need to practice long division with like 21 or 20, I mean, I highly recommend practicing it. That will definitely be on the quiz Friday. So we'll get to the exact how many questions are on the quiz later. But right now, are we cool with the first half of the worksheet? Dividing by a monomial? Should we do one more? Would you guys like to see one more? Number 4. Okay, let's do number 4. Ladies and gentlemen, I'm going to take this entire long, disgusting polynomial, and I'm going to divide it by the 2w squared z. 2w squared z. So again, when you're dividing by a monomial, you do not have to do long division. I don't recommend it. It'd be a horrible mess, right? When you have a monomial, when you're dividing by a monomial, simply divide up that monomial, put this division of 2w squared z, put it on the first one, put it on the second one, on the third one, on the fourth one. So again, negative 6, w to the third, z to the fourth, minus 3w squared, z to the fifth, plus 4w plus 5z. So notice I wrote every term on the top, and I'm going to put that divided by 2w squared z on each one of them. And now all you do is cancel things out. Very simple, guys. Right? So on the first one, you have a negative 6 up on top divided by 2. That's going to be a negative 3, right? That's going to be a negative 3 left over up on top. You have 2 w's on the bottom. 2 cancel with 2 of these 3. You're going to have 1 left up on top. 1 z on the bottom cancels with 1 of these 4. You're going to have 3 left over up on top. What do we have left? A negative 3, w to the 1. You don't need to put to the 1. Z to the third. That's the first term of your answer. Now over here, could I cancel 3 with 2? No, I can't. So it's going to stay a fraction, 3 on top, 2 on the bottom. But I do have w2 and w squared and w squared, which both completely cancel out. No more w's. I have 1 z on the bottom that cancels with 1 of the 5 up on top, which means I'll have 4 z's left up on top. So what's our answer? We're going to have a minus 3z to the fourth over 2 on the bottom. Now the third fraction that we're reducing, 4 on top divided by 2 on the bottom. I'm talking about the coefficient. 4 divided by 2 is 2, and of course it's left over up on top. There's 1 w up on top, 2 w's on the bottom. 1 cancels with 1. There's going to be 1 w left on the bottom. And there's also a z left on the bottom. So my my third fraction will be a 2 up on top over wz. And last but not least, is there anything I could cancel? Well, the 5's don't cancel. There's no w's, but there is a z and a z that cancel, so you could at least cancel out those z's. So your final answer there is 5 divided by 2w squared. That is the answer. Now, I hope we could do the rest of these. I expect you to do the rest of these tonight. Now, this is really part A of 5.2. There's actually a part B. But you're going to love it. It's a lot better. It's a lot nicer. Trust me. Check it out. I know it's a long lesson. Bear with me. If you're watching this at home for the first time, hit pause, get up, splash some water on your face, right? Then come back and watch the rest of this video. Here we go. Okay, put attention, please. Shh. Thank you. All right. Anyways, listen up, guys. We are going to do synthetic division, also known as synthetic substitution. You're going to love it. All right? It's not real long division. It's synthetic division. What does that mean? It's a lot easier, a lot quicker, a lot faster. Check it out. Now, we have the remainder theorem here, and the remainder theorem shows, like, if they ask you to divide this polynomial by this binomial, You could do long division, but that takes a long time. That's why it's called long division. Synthetic division is a lot faster. Let me explain how to do that, ladies and gentlemen. Of course, just like on long division, you always want to make sure that every power is represented. 3, 2, 1, constant. Perfect. And you're dividing by this binomial. Now, let me tell you this. You could use synthetic division when your a value of your divisor, not when your a value, when your leading coefficient of your divisor is 1. So right here, there's no number in front of the x, so you could use synthetic division. How do you use synthetic division? You start by taking this constant value, which is a -3, and putting the opposite value inside a box, inside a reverse L. And then you go back to your coefficients, the numbers in front of each term. What number's here? A 1. What number's here? A -4. What number's here? A 5. What number's here? A 1. And you just make a list right after that box. You draw a line. As you go down, you combine. So there's nothing here. 1 plus nothing is 1. As you go up, you take that number 3, you multiply it by 1. Multiply by 1, and it will give you 3. So that's how we get this 3 up here. As you go down, you combine. What is -4 plus 3? -1. As you go up, you multiply. 3 times -1 is that -3 that we see right here. As you go down, you combine. As you go up, you multiply. So 3 times 2 is 6. As you go down, you combine. And believe it or not, this is your remainder, and these coefficients are the coefficients of your answers. So instead of doing long division on this problem, you could say that your answer is, well, first of all, x to the third divided by x, that becomes x squared. So this coefficient is on x squared. Your answer would be 1x squared. And then the next answer, or next part of your answer, would be -1x. This 2 is your constant, plus 2. The 7 is your remainder, so you'd put plus fraction, the 7 up on top, which is the remainder, over the original divisor, which is x minus 3. So there's your answer that you would get if you did long division. Okay. Yes, it's a shortcut. It's a lot faster, but it doesn't work all the time. It works on many problems, but not on all problems. But let's first understand it. It sounds weird, especially because you're tired right now. It's the first time you see it. We have to practice more. Check it out. Let's look at this worksheet, which is technically part B of the same worksheet. So let's jump to number 7. So let's work through this together, guys. Let's look at number 7. Now, again, synthetic division, you're going to put what in the box? The binomial that you're dividing by. You're going to look at the constant, and you're going to put the opposite value of the constant. So if you see a plus 2 right here, what goes in here? -2. So let's put a -2 right in there, okay? So if it were a -7, you'd put a +7. If it were a +1, you'd put a -1. If it were a -15, you'd put a +15. Simple as that, yeah? Okay, now we need a list of numbers, and it has to be the coefficients of every term on the polynomial we're dividing, and you have to have missing values represented with a 0. We don't have any missing values, so what are the coefficients that go right here on my list? 1, 7, and 10. Now notice I didn't put these too close together. I left some space. Leave some space. And you're going to draw your line like this, but don't put that line too close. You need some space right here. You're going to be putting numbers between the 1 and the line, the 7 and the line, the 10 and the line. Once again, the 1 came from the coefficient of f squared. The 7 came from the coefficient of f. The 10 came from the 10, right? What about this -2? Comes from the opposite of your constant of the binomial you're dividing by. The opposite of the constant of the binomial that you're dividing by. So if this would have been a -7, right here you'd have a +7. If this is a +3, right here you have a -3. Right here you have a +2, it's a -2. Everybody with me? Yeah. Okay, now slowly, carefully, everybody. As you go down, you combine. 1 plus, there's no number there. 1 plus nothing is 1. As you go up, you take this -2 that's in the box, you multiply it by the 1, and you will get what? -2. So let's put a -2 right here. And then as you go down, you combine. What's -7 combined with positive 7 combined with -2? It's 5. And as you go up, what do? You multiply. Negative 2 times 5, negative 10. Now, always do this. On your last number, put a fat line right there. Not fat, but a big line right there. Now, why is that? Because whatever you get down here is your remainder. So what's 10 take away 10? 0. That means our remainder is 0. So what is our answer going to be? Whatever you started with the polynomial of f squared. If you divide that by f, it's going to be 1 power less, right? If this would have been an f to the 5th, then your answer would start with the f to the 4th. If this would have been f to the 9th, your answer would start with f to the 8th. Right here, it's f to the 2nd. What's our answer going to start with? F to the 1st. So our answer is really 1 f to the 1st plus the constant 5. There is no remainder, so that's my answer. And I don't even need a 1 in front of the f. My answer is f plus 5. Now, of course, if I would have had like a 3 out here as a remainder, you would put that plus 3 over the original divisor, f plus 2. If you kind of understood that, you're right on point, because it's barely the second problem. We're going to do some more. Let's take a look at another one. I don't know. You guys tell me. Pick one. 8? 8? Really? That's easy. Let's do something more challenging, like number 9.
13. Number 25.
Let's start with number 9 or 10. Pick one. 9 or 10? 9. Okay, here we go. So this guy goes, well, let's not, if I were doing long division, this would go inside of the box, this would go outside of the box, right? But we're not doing long division. We're doing synthetic division. So let's put a reverse L, and what number goes in here?
4.
Exactly, the opposite of the constant of the binomial you're dividing by. So it's a positive 4. Positive 4 goes right in there. Now, we need the coefficients. We need a list of the coefficients of the polynomial we're dividing, but we need to represent every single power. So the first coefficient is what? 1. The second coefficient is what?
Negative 64.
0. The third coefficient is what? 0. The fourth coefficient was just a constant, minus 64. Let me pause right there. Do you guys understand what I just did? Okay. Now, remember, it doesn't matter if you're doing long division or synthetic division. You have to have every single power represented. A to the third, where's a squared at? It's not there. Okay, so it's a 0, a squared. Where's a to the 1 at? It's not there. Okay, 0, a to the 1. Then minus 64 is minus 64. So you need these place values. If you don't put those place values of 0, it's not going to work. Okay, let's do the line. As you go down, you combine. 1 plus nothing is 1. As you go up, 4 times 1 is 4. Put that 4 up there. As you go down, you combine. 0 plus 4 is 4. As you go up, 4 times 4 is 16. As you go down, 0 plus 16 is 16. And as you go up, 4 times 16 is 64. And again, put the line right here, because whatever you get over here is your remainder. And in this case, again, the remainder is 0. So what's our answer to this? If you started with a to the third and you're dividing by a, think about a to the third divided by a, that's going to give you a squared, right? 1a cancels with 1a. There's 2 a's left over. A squared is part of the first term of your answer. So you really have 1a squared. Let's write that down. 1a squared, or you could just write down a squared plus 4 for what? A, and then plus 16, and then plus, you don't have a fraction, you're done. You see, it's easy. Está fácil. Está fácil, güey. Okay. Ese, güey. Okay. Let's do another. Obviously, it gets a little more challenging, right? Let's go for one of the craziest ones. 17. Yeah. 17. So we have this polynomial divided by this binomial, and because the a value is 1, I'm going to use synthetic division. If I had a 2 right here, if I had a 2x minus 3 or a 5x plus 2, I would not use synthetic. You could use synthetic, but you'd end up with fractions, so I would just say stick with long division. If you have a value in front of your x, stick with long division. Yeah, so synthetic division works best when you're dividing by a binomial that has 1x and then any number. Okay, if you have a 2x or a 3x or a negative 5x, I would go with long division. It's your best bet. You could use synthetic, but it gives you fractions, so let's not even go there. So right here, what goes inside my reverse L? Negative 2, that's right. Now, give me the coefficients of the polynomial we're dividing by. 1. Negative 3. 0. Then 5. And then negative 6. Guys, if you don't put this 0, you're done. Okay? I didn't say you're dumb. I said you're done. As in, you're not going to get it right. Okay? So look. 1 is in front of x to the 4th. There it is. There is an x to the 3rd, so negative 3 goes right there. There's no x squared. So you have to represent the value of x squared with a 0. 0x squared. Right? And now, let's do this crazy hard problem. Look how quick it is with synthetic division. The 1 plus 0 is 1. The negative 2 times 1 is negative 2. The negative 3 minus 2 is negative 5. The negative 2 times negative 5 is positive 10. The 0 plus 10 is 10. The negative 2 times 10 is negative 20. The 5 take away 20 is negative 15. The negative 2 times negative 15 is the positive 30. Everybody with me?
Yeah.
Yes.
Put the line right there. What's your remainder?
Negative 24. Oh, no.
24. So what's our answer going to be? It's going to be a 1x to the 3rd minus what? 5x squared plus 10x, then what? Minus 15, and then plus the remainder. So I want to put plus. Now, because it's a remainder, you're going to put a fraction right there. Now, by the way, if this would have been a negative 24, I would have put a minus right here. But it's a positive 24. I put a plus. I put the 24 up on top and the original divisor on the bottom. The x plus 2 that we were dividing by, put that on the bottom. And ladies and gentlemen, we are done. That's your answer. So why do I have a fraction at the very end? Because the 24 was my remainder, right? And any problem, any division problem, like let's say I told you, you already know what 5 divided by 2 is, right? What's 5 divided by 2? What's half of $5? Come on, guys. $2.50, right? 2.5. So if you're doing long division, right, you would say 2 times what gets you 5? Oh, 2 times 2 gets me close. It gives me a 4. And when I subtract, I'll have a 1 left over. What do you do with this remainder of 1? You put it on top of the original divisor. So that's how you end up with a fraction. And remember, synthetic division is just a shortcut for long division. And whatever you end up with over here, that's why we put the line right here. Whatever you end up with over here is a fraction. I mean, not a fraction, it's a remainder. And the remainder, you put it over the original divisor, and that's why it becomes a fraction at the very end. Cool? All right. Should we do another? 14? Sure, why not? Let's do 14, and then you'll be off to do the rest of this, right? So it is a division problem. What goes inside my reverse L? Negative 2, perfect. What is it? It's simply whatever your binomial is that you're dividing by, look at your constant and think opposite. Right here it's a plus 2, so it's going to be a minus 2. Now, could somebody read me the list of the coefficients that I have right here? 6, 15, negative 8, 0, and negative 6. Perfect. You see, it's easy if you're paying attention. If you're talking, you're not going to get this. As you come down, you add 6 plus nothing is 6. As you go up, negative 2 times 6 is negative 12. As you go down, 15 minus 12, that's 3. As you go up, negative 2 times 3 is negative 6. As I go down, I combine negative 8 minus 6. What's that? Negative 8 minus 6?
Negative 13.
Negative 14. Don't make a mistake. And then as you go up, negative 2 times 14, or negative 2 times negative 14, positive 28. As you go down, you combine 0 plus 28? 28. As you go up, multiply negative 2 times positive 28, negative 56. Let me write that up there, negative 56. Now remember on this last one, put that line, because whatever you get is going to be your remainder. So what's left over? What's your remainder? Negative 62. So what's my final answer going to be? 6 y to the third. Now, why is it y to the third? Because it was originally a y to the fourth. If you divide by y, it's going to drop it by 1. It's going to be y to the third. What's the next part going to be of my answer? Plus 3y squared. Then minus 14y. And then plus 28. And then minus. Now notice I put the minus first, and the 62, I'm just going to write it up there. I'm not going to put a negative 62. This negative sign, I want to put it out here as a minus, and it's going to be over the original divisor, which is y plus 2. Ladies and gentlemen, that's good that you guys picked this question. You know why? First of all, it's fun to do, but also if you look at your answers on the back of your other worksheet, all right? The answers are on the back of the other worksheet. The answer is incorrect. It's a typo because they actually gave an answer to a different problem. If you look at the answer sheet right here, instead of a negative 8y squared, I think they have a negative 28, huh? And that would change everything. This would be a negative 28. That would even change the remainder. It would change all this whole part of it. So again, maybe on your answers, go ahead and cross out number 14. Because that answer is incorrect. If you want the correct answer to the one that we just did, here it is. Here's the right answer. Okay? You know what? This is a super long video. Another minute or two won't harm anything. Check it out. This is called synthetic substitution as well as synthetic division. Why? Because you could actually use this synthetic method to substitute. Now, what if I told you, go ahead and substitute 2 for x? Well, you would have to do 2x to the third plus 5x squared, minus x plus 7. And you'd have to plug in the 2 right in there. Let's do some math. What's 2 to the third? 8. What's 8 times 2? 16. What's 2 squared?
4.
And what's 5 times 4?
20.
Positive 20. I forgot to put the 2 right here. I'm sorry. And then we have a minus 2 plus 7. What's 16 plus 20? 36. Minus 2 is 34. Plus 7. 34 plus 7? 41. Ladies and gentlemen, that's the answer, right?
All right. Okay.
It was a lot of math that we did right now in our heads. There's a lot of opportunities for mistakes. You could use synthetic, not division, synthetic substitution. And this one is direct. You still do the reverse L, but whatever value you have right here, you put it in as that value. You don't think opposite. You put in that exact value, and then you do the same thing. Your coefficients. Well, you have a coefficient of 2, put the 2 right there. The coefficient of 5, put the 5 right there. Coefficient of negative 1, coefficient or the constant of 7. Do your line. The 2 comes down. 2 times 2 is 4. 5 plus 4 is 9. 2 times 9 is 18. Negative 1 plus 18 is 17. 2 times 17 is 34. 34 plus 7 is 41. Same answer, just done quicker. So I just wanted to show you this example of why they call it synthetic substitution, right? Because you could also use it to substitute without doing this whole process up here. But synthetic substitution is not on your worksheet. Anyway, please complete your worksheet. These exact type of questions will be on the quiz Friday.